didn't say I had a comment. I said I feel like making one. I feel like it's more slicked and like than normal.
I could just shake my head and it would be good.
I'm not saying it's bad. I'm just saying it's just like more try than normal. Okay, number 6 was the number of people who owned computers increased by about 28% annually since 2001. This is, what did we say, number 6? 28% annually since 2001, right? If 2 million people owned a computer in 2001, predict how many will own a computer in 2006. 26. Just kidding. LOL JK. Okay. In the year 2525, if Matt is still alive.
I wonder if anybody will be dead by 2026 that's in this class.
I hope not.
I hope not, but like,
It's 4 years today?
yeah.
I
But
hope
I still
not.
wonder. Cause you never know.
Be sad.
It's
happen.
You never know. You see, we live in a society. Wow. A society. And one night he goes to the city council meeting and he goes and
2026 isn't it's 4 years.
Oh. What should we do?
We should
Gather
plug
our
in the
info.
weird bit,
Oh, I mean like in like
put it together.
For like the T and the P and all the stuff.
What's the formula?
y equals a plus b times b. I don't know how to word it, but it's a in the parentheses 1 plus r.
Oh yeah.
To the power of time.
No, it's y equals P to the parentheses of
Same difference in this problem, but yes. Functionally, some letter right there.
So does it matter what letter?
No. It's just talking about something specific. The formula is the same either way.
I accidentally just threw my
So, what should we do now?
We should plug in the numbers.
plug in the numbers.
Okay.
Y equals 2 million times 1.28 to the power of 25.
25.
Where did
Two.
25 come from?
I don't know. Where did the 25 come from?
Shouldn't it be 28?
So, it's between
Oh, I know.
years between 2001 and 2026.
Oh.
So that's the time we're looking for.
Yeah, that's gonna be.
Okay.
So where'd the 1.28 come from?
So it skipped a step, right? So
Yeah.
okay, never mind. LOL JK.
Now keep going.
So then we stick that in our calculator and pop out an answer. Oh yeah. Oh yeah.
That sounded like the Grinch.
No, it didn't. It sounded like the Kool-Aid Man.
Kool-Aid Man.
Or we could do everybody's favorite or least favorite Star Trek man and say, "Oh my," which wasn't a very good what's his face impression, but you know, it was at least a try.
Guy with pointy
What's his
ears.
name? Sulu was his character. What's his name? Decay. George
Okay. I knew that.
Oh, right.
What was it? What was the answer? I don't have one. Where'd we get the I don't know how to do this either.
478.9.
You could have just said 478.9. Okay.
I don't like saying numbers.
Really?
Yeah. It happened since like 6th grade. Garrett likes to make fun of me for it.
He can't say numbers either.
He can say numbers.
He can?
Yeah. Like
big numbers.
Oh, the big
I have
numbers.
to think about big numbers for
Me
like
too.
5 minutes.
Like big numbers with decimals, I hate those.
Decimals are easy.
So 0.255.
No, big numbers with decimals, like 1,000,000 something 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 point blah blah blah. I hate those.
So you end up with 900 million some odd. Does that sound right?
I got
No.
9. Yeah, I got 900.6.
I got 478. Oh wait, no, I didn't finish the problem.
No, the answer is 957. I got 960 million. If I'm rounding.
It doesn't say round.
Okay, then I'm not rounding anymore. 957 million. 809,713. So where did we get the 1.25?
The 1.28, you mean?
Yeah, the 1.28.
Why'd you say you got it when you don't got it?
Where did you get it?
OMG, you made me have all that excitement for nothing. So it's a skip a step. So in order to, first of all, in order to use this guy, what do we got to do with it?
I got it this time.
In order to use this guy, what do we got to do with it?
Turn it to a decimal.
Right? And yeah, and then we plugged that into here and added it to 1 and got there. True facts. Now we double got it. Double got it. Any other questions about this homework?
We do 10.
I don't know. Can we?
No, can we do all of them?
How many lessons are there left? Bunch.
Yeah, are we gonna get to module 8?
No.
Modulate.
So that's what I'm unit 8.
You can call it whatever the heck you want to call it. I've been calling it units, but the book calls it chapters, and modules also work. So you can. Who the heck cares? Who the heck cares?
Oh wait, oh yeah, it's science.
What did somebody ask for some actual problem before I started yelling about who knows what? 10? 10. I am a 10. Thank you very much. 10 out of 10. Yes.
We're going to take that instead of the.
Yeah.
Watch me whip, whip. Watch me nay, nay. Do the stanky leg. Brooke is saving money for a trip to Padre Island National Seashore. So sweet, Brooke. Padre Island, because Texas. Okay, because Texas edition. They're like, look, we're relevant. And it costs $295.99, probably plus tax. I feel like this problem is like a scam, but it's okay. She puts $150 into a savings account. There's a little savings account. Isn't it cute? It should be a pig. Let's make it a pig. Piggy bank, right? And then face. How do you make a pig? Big nose. Because she's putting it in a savings account. That kind of looks like a pig. Sure, why not? That's a pig. Why not? You probably could have guessed that from Pictionary. Okay.
It's got wings.
Yeah, I don't know what happened at the top of it. It's a slice. It's being turned into bacon. Okay. Except that usually comes from the belly, so whatever. Okay. So she put $150 into a savings account that pays 7.25% interest. Compounded quarterly.
Does that mean it'd be compounded
Can we
like
talk
every
about
3 months?
investments?
Quarterly. So how many quarters are in a year?
4.
4. So yes, every 3 months, but what we're interested in is the number 4. You're right.
So I did 3 because it would be every 3 months.
No, it's because remember it's a fraction of a year.
So it's going to be 4 or is it going to be 1/4?
N is 4.
Is that?
That's compounded quarterly.
Okay, so if it's quarterly. Okay.
You're in trouble.
I don't need that there. Here. Aren't you cute? And she leaves it in there for 4 years.
Nice.
And she wants to know, can she go to Padre Island? So, what should we do?
Make an equation.
We should write out our equation. What equation are we going to use?
Y equals A times 1 plus the R of n.
One over T, right? R of T.
No, it's not R of T, it's R of n.
Okay, now what?
How do you get any T? A is going to be 295.99.
Nope. That's not what she put in. That's a lie. She put in 150 in the account.
Never mind.
She's hoping to have $295.99. Right? Did you say it's illegal? What did you say? I'll leave you alone. No, not my job to leave you alone. It's my job to harass you till you learn something about math. What is R in this problem?
0.725.
Nope. 0.0725. And N is 4, which it's sounding like that is the main place where we made a mistake here, right?
Yeah.
That it's compounded quarterly would mean N is 4. Because it's a fraction of a year. Like monthly is 12, right? Or semi-annually would be how many?
Semi? Would be 6.
2. Semi-annually is 2.
So
Twice a year.
semi-annually of 8 is 4.
No.
So
Twice.
what it be to the power of 16?
Stop it. That's not what we're saying at all. If it was compounded semi-annually, then N would be 2. That's what we're talking about.
So where did we get the N from?
The formula for compound interest.
Question. So
This is the formula for compound
I
interest.
thought the formula was Y equals
That's the formula for exponential growth. With compounded interest, we add the N because it can be compounded some amount of time.
Okay.
Does that make sense? So there's 2 exponential formulas that we have. 2 of them. One of them has an N, which is for money, and the other one doesn't. If it's compounded annually, then N is 1, and it's the same formula as the other one.
When I put that in my calculator, it says syntax error.
Which means you didn't type it in right. And the word is syntax. Yeah, so I wouldn't try to put it all in at once, for one thing. So A equals 150 times, what's 1 plus 0.0725 over 4?
2.518.
There's no way that's right. Actually, I may be lying, actually. You may be right.
There's no way.
Let me verify.
1.018125.
I don't know 0.29. No, I did it wrong though. Never mind. That's wrong.
I don't have the calculator. I'll tell you, last day
If that's true on Tuesday, you're liable to have problems.
We're taking a test on Tuesday.
Yeah,
What? I thought we were studying. I thought we were studying on Tuesday.
we'll see. Depends a little on how the day goes.
Wait, hold on. How are we going to take a test
Stop crying.
if we don't finish modern?
Oh, then you won't take a test. Brilliant.
I feel
So it does end up being 1.018125. When you punched it in, Mark, did you accidentally do the plus first instead of the other, maybe? Like this right here, make sure that when you punch that in your calculator, I would, whenever you put fractions in the calculator, I would make sure and put it in parentheses. It'll lead to less weird problems. That's probably so.
What I usually do is I'll do it after I've divided it.
Well, okay. So then you may have punched something in wrong, because that would also work.
What was the answer?
No, that's not the answer.
I'm confused. It keeps on popping up with the syntax error. Saying syntax.
Okay.
I don't know.
Are you plugging in just what's in the parentheses?
I'm doing 1 plus the thing.
Well, you're doing something horribly wrong. Let me come look. So horrible. You're going to make the world explode.
Probably. It's not very cool. I don't know what I'm doing.
Well, punch it in. Let me see what you're doing wrong.
So I do 1 plus 2, 3, that thing.
Well, you can't use the fraction button if you're sticking a decimal in there. What's fraction the same as?
That's. Oh, division, yeah.
Yep.
Okay, now I understand.
Enter. Yeah, it doesn't like that. Some calculators will let you do that, but many won't. Yeah, that's where the sign tax comes from. The tax on the sign. Okay.
Side.
Best practice, by the way, is to leave that answer in your calculator.
What, side tax?
No. The answer you just got.
What? What was the answer? I got it.
And then you would do what next?
You square it. I mean, not square it. You
Six.
multiply this.
Raise it to the 16.
Yeah, that.
Right? So I would leave what you got in the calculator and then just raise that to the 16. Don't round until the end if at all possible. Oops.
Oh, I did 46.
And then the last step would be what? Multiply it. So then you still should have something, that number in your calculator, unrounded, and as long as your calculator will let you do it, and so you just push times 150, enter.
On number 8, my calculator put it in scientific notation. And I don't know.
Probably because we have our calculator set for scientific notation.
That's possible, or it's just a really big number or a really small number.
It was a really big number.
Yeah, that's why.
Can you write it in scientific notation and it'd be right, or do you need to? Or do I
If
need
you
to-
got on number 8, if you got a number so big that it needed scientific notation, you probably did something wrong.
Should be round because I got.
Because it shouldn't. It's the number is 7,000 some odd.
There you go.
Should be round.
What is this? What is the units of this?
Oh, dollars, you're right. Yeah.
So $199.94. Are we finished? Are we?
95 cents.
Well, then you rounded differently, didn't you? That's why I was suggesting you wait until the end, right? Right. Now, so we're not quite finished with the problem yet.
She will not have enough.
Yeah, she will not have enough. She's short by almost $100.
That sucks.
Poor thing. Maybe she should get a job. Okay. Any other questions on this? No? Okay, moving on. 7.7. Geometric sequences as exponential functions. Geometric sequences as exponential functions.
Is this 7.7?
Yep. Okay. No, not geometry. Lies. Geometric sequences.
So geometric sequences is not a part of geometry?
Nope. I mean, yes and nope. And geometry may not be what you think it is. But you will learn soon. Soon and very soon, you will learn to see the proofs.
No.
And then you too will understand any of the memes where you see, prove that this is a triangle. How do you know it's a triangle? Because it's a triangle. No. Because geometry is actually a theoretical math class in disguise.
You mean geometric?
No.
Geometry.
You're welcome.
It really isn't all that funny, but whatevs. You're allowed to laugh at what you think is funny.
Well, I always call sequences squeakins.
Okie smoky dokie. Okay, we're going to jump in with some examples, and through examples, we're going to get definitions. Sound good? So the instructions for the examples is, what do you mean no? Quit crying, don't do it. There's no crying in baseball. Okay, now,
Yeah, there is.
if you've never seen A League of Their Own, you're missing out. It's sort of based on a true story, sort of. Determine. Whether. Each sequence is arithmetic geometric or neither. And example 1 is this sequence. Whoa, that's ugly. Try again. 256. 128. 64. 32, etc.
So it keeps getting smaller. You can
True
cut it in
facts.
half. It does get cut in half.
True.
Wait a minute.
This, and we'll see if we can explain. It does keep getting cut in half. That's true. What do you mean, wait a minute? Why are we waiting a minute? No!
Hey,
We don't want to wait for nothing. Okay. So this sequence right here is geometric.
because it gets cut in half.
Well, we're gonna see counter examples of arithmetic ones and neither ones.
Does the arithmetic keep going up in halves?
Well, we shall see.
Watch it.
Watch it. Ooh, watch me, watch me. Okay. 4, 9, 12. You can't take what anymore?
Ooh, watch me, watch me. Ooh. EXE stuff. Math class gets real when the teacher does the stanky leg. Ridiculous. Some of it would.
I don't like this example,
Rick and Morty just starts.
but it's okay. It's okay. I don't like this example at all. We're gonna kill this one. And we're gonna use this one instead, because this one's better. These one better. -20, -15, -10, -5.
Oh,
It only goes up.
goes up by
It goes up by 5 each time. This is arithmetic. This is an arithmetic sequence.
The example we were doing was 4, 9, 12.
Well, it was also arithmetic, but sort of. But that's why it was a bad first example. Now you understand why I switched, why I pivoted. Pivot.
Watch me.
Next one.
Last day of class, we need to play Watch Me as our test.
I don't know why I hit the pawn in math class.
Hit the woe. Aiden, hit the woe. That's not the woe. That's the whip. That's a different W. 2, 8, 14, 22,
Goes up by 6.
etc.
Does it go up by 6?
Arithmetic. No, it doesn't go up by 6.
This one. This one right here. This one right here is neither.
I knew it. Totally right, that was the only one left.
Alright. By making my assumptions, I assume that geometric is division or multiplication, arithmetic is addition or subtraction, and neither is when it doesn't go up like the same amount each time.
That's
I really
that's
wanted-
close.
I really wanted him to give a full explanation. He was like, no, that's not how.
That's close. Very, very close. Let's do something with these sequences.
He's so proud.
Let's do something else with these numbers.
Hey, no, hold up. We don't need to start that. Oh wait, that's just 2. No, it's not. Shut.
Quit crying. What is 128 over 256 reduced to?
1/2.
What about 64 over 128?
1/2. I really think that.
And 32 over 64?
0.5.
Oh, so it increases by half? Oh, wait, no, decreases by half.
Man, I got this little dance and all that short.
And that reduces to 3/4.
It does.
So it decreases
And then this one.
I don't know.
We don't know. We don't know what's happening over there. So they don't have a common ratio, right? What's the next one?
What happened?
But they do go up by a consistent number. So, here is the moral of the story. Are you ready? Are y'all ready for this? I don't think you're quite ready for this.
A. I knew it.
Dang.
Ayla. Aiden. Yeah. You're kidding. It's the word will.
Was right or wrong? Right.
Yes.
I don't think y'all can handle that. But
No.
yes, but Aiden was right.
It can't be.
Okay. Let's do another type of example. Well, all of y'all probably figured it out too. He just was brave enough to say it. So, good job. Good job.
Man.
Okay, let's do another example.
So, geometric, do they always decrease?
They haven't.
Or
No.
do they increase?
They can increase as well.
As long as it's in increments of half.
No, it doesn't have to be half. If they have the same ratio. These are all halved. They could be another type of another example of a geometric sequence would be 3, 9, 27, and then whatever the heck comes after that.
They all have a common denominator.
Aiden, stop being like not cool.
They have a common, not denominator, there is no denominator, but factor.
Yeah, they all have a common factor.
Yes.
And then arithmetic is when they're increasing or decreasing in even numbering.
They're linear, if you will.
They can technically have a common denominator.
Okay, that's true. That's true. So let's do another type of example. Find
I'm not good at searching.
you've been doing problems like this since probably third grade. Just saying. The next terms in each geometric sequence.
Oh yeah, I love this. I love this stuff.
You were just griping about it. Every time you say that, then the next class you come back and it's like, I don't understand this at all. That's really pretty much how it goes down every time.
But do I pass? I normally pass.
You do now. You didn't at first. Look at you learning and getting smarter. We're so proud.
Hey.
That's what we hope for, isn't it? If you started the class mediocre and you ended the class mediocre, then was it worth it? No, it wasn't. If you started the class mediocre and ended the class great, did you get something good out of the class?
What if you
Yes.
started mediocre and ended terribly?
Well, then you definitely didn't put in good effort in that class. Fruit tracts. Okay. Example. Okay. Example, we'll call this example 3. Yes?
Can it be 4 though?
Yes.
Oh, yeah.
Bree is being rude today.
No.
She took her rude pills. 1, -4, 16,
What? Now I don't like this anymore.
-64. So what would the next term in the sequence be?
Be positive.
It would be positive something, that's true.
This is geometric.
that's in the instructions. So yes, it is. It does have a common ratio. So what would the next term in the sequence be?
4,096.
Bro, if that's right.
That's too much.
Is it 96?
Ooh, here.
To get to the next one,
Or negative 256.
and then to get to the next one would be, right? To get to the next one, it would be, what's the Horatio right here? -4/1. It's always not 4, that's so close and yet so far. No, it's not 1/4 either. It's always -4. So to get to the next one, what would you do?
Multiply times 94.
Yeah. And you would end up with what answer?
Negative 256.
No, positive 256.
Positive 256. Blapo. How we doing? Let's do another one. Example 5. 9, 3, 1, 1/3. What would be the next term in the sequence? Calm down.
133.
What did you say?
So like 9. Okay.
It's always 3.
It's gonna be subtracted by 1/3. Like you know how in 256, 128.
Oh, we didn't write all of the instructions. We should write the rest of the instructions and finish this problem. The next 3 terms.
Oh, come on.
Because then we can get to Aiden's first answer. What will be the next term in this one?
4,000.
No.
Negative 1,024.
-1024. What have I written?
And then the answer is the next
And then the third one, the next one would be what?
4,096.
4,096.
Man, look at this new day.
When I first saw the problem, I thought that it was going down, and then you multiply the down number by itself.
You are making things very complicated.
Yes,
Okay, so what would be the next 3 terms in this sequence right here?
What's 1/3 divided by 1/3?
Math, man, math. And that's actually not right. You wouldn't actually do that because that would get you the wrong answer, what you said out loud.
Divided by 3.
I don't know. What is 1/3 divided by 3?
I'm not gonna again. It's just
It's the same thing as 1/3 times 1/3, isn't it? Because dividing by 3 is the same as times 1/3. Yes, yes. True facts.
it's always 3 on this problem.
What's the next number?
2/6.
No.
Wait.
That's not even a reduced number. No.
Nines.
Yes.
So what are we multiplying by? 3?
1 9.
No, we're not.
We're multiplying by 1/3
Why?
because that's how you would get to here.
And then 127.
I divided by 3 and got the same answer.
Yeah, 127.
Because dividing by 3, that's what I just said. Dividing by 3 is the same as multiplying times 1/3.
Then 181. Then 181.
Yeah, 180 first.
I'm so confused.
Mira. This is how we'd calculate the ratio, right? Yes. So the ratio, we're multiplying by 1/3 each time. Because 9 times 1/3 equals 3. 3 times 1/3 equals 1. 1/3 times 1 equals 1/3. What's 1/3 times 1/3? 1/9. What's 1/9 times 1/3?
1/27.
And then the next one would be what?
1/81st.
Good. Let's do another one. This one will be a guided practice. So this will be GP number 1.
GPs.
So here's your sequence. -3, 15, -75, 375. So list the next 3 in the sequence. Ready to go.
Is this geometric?
Yes. I mean, I probably should have said, is it? But yeah, it's the same instructions as before. So there's where we should have ended up, right there. Any questions there? Okay. All right, hold on to your bonnets because we're making a audible.
Can we do a quiz?
No. We will not have another quiz until the last test. We ain't got time to waste.
So we will all have a quiz.
You will have a test the last day of school. That's the last formal assessment you will have in this class.
Is the last day of school on a Tuesday?
No.
No.
It's on a Thursday.
Right, it's the 19th, so 2 more weeks.
All right, we about to pull an audible, so hold on to your hats.
Oh, God, no.
Okay, then you're gonna get left behind. Lesson 8.1.
Oh, no. I don't have any more paper. I actually don't.
Well, then you're gonna have to figure that out. Adding and subtracting polynomials.
Do you need paper?
Your last test, by the way, is going to cover material from units 7 and 8. Anything we've covered since after the last test. Don't gripe. Nobody likes a griper.
I'm about to cry.
Okay, good. That's my goal.
It's better than covering all that we've done, Ryan.
Buddy. Oh, pal. Oh, adding up we got this. Oh, no. I don't like this.
Polynomials.
You see, when you start making up words, I don't like math.
What kind of polynomial is this? (4a minus 6b).
What's a polynomial?
This is a binomial
But it's got 2 numbers.
because it has 2 terms.
Oh, terms.
Terms.
Binomials.
This one also is a binomial. -8,000 xy plus BL. This would also be a binomial. Savvy? Makes sense. Any questions thus far? No?
Did you say savvy?
It has 4 though.
No, it has 2 terms. Where are they? What is the first? That's a good. I'm glad that you pulled that out. Very good. So this is the first term. This is number 1. This is the second term. Same idea here.
So I have a question. So it's a binomial because it's got 2 terms.
True.
What if you did -800 plus xy plus bl? That would be
3 terms, and it would be a trinomial. That's yes.
It just depends on where you put the
Yeah.
It does say secret
Read the future, girlfriend. That's obviously what we're about to talk about.
Is there about to be a polynomial?
We don't usually talk about anything beyond a trinomial and name them. Polynomial is a multi-termed
So it could be
expression.
like, you know, more-
So, these x squared minus 3x plus 4. This is a trinomial.
So is the,
So is this. I'm listening.
I lost my words.
AB minus 62x plus 3. This is also a trinomial.
Okay, so a trinomial is just 3 terms.
Yes.
Yes. So I'm assuming on a test, it's gonna be like, what is this number, polynomial, and we have to decide.
That might be a type of question, yes.
Probably gonna be like solve this equation and tell what type of polynomial.
This is a monomial.
One.
I thought it was unomial.
So is this. Hello, machine. These are polynomials.
Not the monomals?
No. Poly means many. These are also polynomials.
What's that called?
It would be a four-termed polynomial.
So anything that has more than one term is a polynomial?
Yes.
And are the terms just, they're not just variables, they're numbers as well?
Yes.
So any equation is a polynomial.
No. An equation might have a polynomial. Polynomials are expressions, therefore they wouldn't have equals. Right?
My mom.
Okay. A little more vocab.
I like these things.
What time is it? LOLJK. Homework.
Some more vocab. Homework.
The definition
So that
of
one.
homework. Working.
Page.
It needs to be 1 or 4 or 5.
441. Numbers. (14) through 24
Oh,
evens, and page
my mother. Where you live in SSI?
468. Numbers 2 through 6 evens.
That's not bad.
So,
Goodbye, chitlins.
So,
cool. Is homework set number 1 the stuff we went over in Unit 7?
Mm-mm.
Okay, very cool. Very cool.
this is bad
Yes,
when
it
I
is.
changed
Simpler times back then.
Because now I have I've lost everything.
Now you have lost all the colors.
Yeah, I've lost everything that I started with except my books.
Because you don't understand how backpacks work, apparently.
And backpacks.